Hello, I'm Aleksandra Skrzypczak. I'm co-founder of Golem, and I'm here to tell you about the current stage of the project, what are we working on right now, and what you can expect from us in the future. So, like, the most interesting part is in the middle of this talk, so stay with me. So what's Golem? Golem is the decentralized market for computing power. So if you're like a developer or a professional that needs to run a huge computation, you can rent computers from our network instead of paying for this huge cloud provider. And if you like normal users with powerful machine that is online all the time anyway, you can share it with our network and earn some tokens for it. So where are we? We're live on mainnet since April with the first use case, which is Blanda rendering, and there are like 6 to dozen hundreds of nodes connected to the network that Blender artists can use. It's a beta stage, and it's beta because we're still missing one service, which is called consent, and it's used only in a case of conflict between requester and provider. There are 5 use cases that needs to be implemented. 3 of them are already on testnet since the last major release, and 2 additional use cases are implemented, but they are just passing security and scalability tests. We're collecting stats from the user to improve the UX and add new features. For example, recently you can choose what kind of computers you want to work with. For example, just to rent computers that are like 2 times more powerful than your machine. And we're working on adding GPU support. There are like 2 alternative implementations in our repository, and NVIDIA Docker-based implementation should go live in like next few weeks. That's how our application looks like. If you haven't tried yet, I encourage you to go to golem.network, find the download instruction, install it, and just play with it. We've got Windows, Linux, and macOS version, and we're trying to make it more and more user-friendly with every version. For example, you can see this improved task list where you can check more stats that was added in the, it is going to be added in the next release. Okay, so what else are we working on? Verification. When someone hears about Golem, the first question that they usually ask is, how are you going to verify the computation? And that's actually a pretty good question, and there's no easy answer. Especially that, like in the world that we're living, it's not deterministic. In a blockchain space, we're used to deterministic smart contract, and we want to use something like true-bit algorithm where we can compare the data bit by bit, and where there's one bit of difference, then one of the solution is wrong. But like in the real world, it's not that simple. For example, in Blender, you can have 2 pictures that were rendered correctly, but they are slightly different. You cannot see the difference with your bare eye, but if you compare the pixel RGB values, you can see there is like, you know, 1 point difference, or like there are some differences on the edges of this machine. So how can we deal with it? We can use image comparison algorithm, and our CGI team used machine learning to create this decision tree and train a classifier that is using different image features to classify properly images as to one that were properly rendered or not. Okay, apart from that, I'm talking about Blender, which is the first supported use case, but Golem is not a render farm, especially it's not a Blender render farm. We want to make it a generalized solution for generalized computation. So we're exploring new use case space, we are implementing machine learning use case, we are implementing video transcoding, we're playing with scientific computation, neurobiology, cryptocurrency mining, and we're still looking for new use cases that can be implemented. So if you're a developer and you know a use case that might be like a good fit for Golem, please contact us. We'll reach back to you. We'll try to make an interview and try to figure out if it's a technical fit. And if it is, we can try to create integration together. There is some grants program. And just keep in mind that there are some technical boundaries. Like, for now, you cannot send too much input data. So if your input data are bigger than 1 gigabyte, it's probably not a good use case for Golem right now. Also, keep in mind that those 600 computers that are in the network are distributed across the globe. So they're not a cluster. You need computation that don't need to be synchronized so often. Just can be run in a completely distributed manner. Okay, so now that's the cool part. Because there was this first question, how are you going to verify the computation? And there is the second question, how are you going to protect the data? And one potential solution for both of these questions is Intel SGX technology. Like, for years, people were working on solution to protect the host machine from the software that is run on it. But like, the concept of protecting software from the host is still like slightly new. And hardware solution might be an answer here. So there is Intel technology that you can use to make sure that no one is modifying your code and no one can check the data that you execute there. Sounds cool, right? So why people are not using it in production so often for bigger application? And the answer is that it's not easy to create code that can run inside enclave. You have to write C++ code that is especially compiled for SGX, and you have to predict where you're going to make all the operation system calls and replace them with the proper SGX calls. So you can write small applications like that, but rewriting a huge part of code, especially if you're using some external libraries, that's really difficult. So how can we solve it? People are working on libraries that are translating these system operation calls into SGX calls, and there are like several projects that are doing that. Especially cool one is called Graphene, and it's cool because this layer, platform adaptation layer that is making calls to operation system is especially narrow. And in that way, we can only have these well-tested, well-defined calls that are minimizing this interaction with untrusted environment. Sounds cool, right? So why people are not using that in production? And the reason for that is that it's like a scientific side project, and it was not production ready. There were many bugs in the code, some race conditions, and if you try to run multi-threading application, it fails badly. So our friends and partners from Invisible Things Lab started to working on Graphene, modifying it, fixing bugs, and improving it in a way that allowed to finally run bigger multi-threading applications like Blanda. Additionally, what they've added is Docker integration and ability to make sure that the code that was executed in this Graphene wrapper was really executed in the enclave. So we get data protection and verification at the same time, and you don't have to write your own code. You can use arbitrary binary, just wrap it in our Docker container prepared by Invisible Things Lab, and it's working. So one more time, why that's important and why it can be used also in other projects, not necessarily only in Golem. You don't have to write your own C++ code. You can use arbitrary binary. You can take your Docker image, just modify 3 lines, inherit from the Docker that was prepared by ETL, add manifests that describe files that are needed to be put inside this enclave, and voila, you have the same security level, verification, and protection of the data, and data ready. So why people are not using that? Because they haven't heard about it yet. But yes, that's something that is really going to modify the blockchain space, so please check this Docker. Okay, there's one but. So if you run application inside enclave, there's like limited memory that is that you can use. It's like 128 megabytes of data. And if your application requires more memory, it will require some on-fly paging that is supported by Intel, but will like reduce the efficiency of your application. It's not a huge difference, so if you're not using memory in a very strange way, like making some random calls, just normal input and output operation, it shouldn't be more than 30%. And yeah, we were able to run our Blender Docker with these promo video images that some of you maybe have seen inside enclave, and rendering time was pretty nice. Okay, so what else are we working on? Clay. So if you remember our roadmap from the white paper, the next stage is going to be called Clay, and it will be this generalized application with better task API. And we have a team of our best developers actively working on it. And it's not longer gonna be written in Python, so the parts that they are creating from scratch or they're fixing it in Rust. Marketplace. So marketplace is like this central component of Golem where you're matching providers and requesters and trying to achieve two different goals. Like for providers, you want to maximize the earnings, and for requesters, you want to minimize the cost of the computation and minimize the time of the computation. So how can we fulfill those two opposite goals and in the same way make the market more balanced? Algorithms that we're using right now are really, really simple. So we have this research team of scientists and mathematicians working on improved model for the marketplace with provider selection function and task selection function. I'll give you a short glimpse on the next slide. Then we have this side project which is called Unlimited, Golem Unlimited, which is a Golem that is designed for small data centers and corporate networks that allow you to form some clusters and have decreased trust requirements. So you can have your company network represented from the external S1, very powerful Golem node, and inside this network you distribute the data in a slightly different way. We are also exploring other direction towards SGX and further usage of SGX. What I forgot to mention is that with Invisible Things Lab, we've created a fork of Graphene, which is called Graphene NG, so you cannot find this Docker container and improvements in original Graphene repository. You can search our repository for Graphene NG. And apart from these two issues, so verification and securing the computation, it can be also potentially used for decentralizing the consent service, for making consent service more efficient. And also there is potential problem of liberalizing SGX, so it cannot be verified not only by Intel company, but also by other people that can sign the enclave. Okay, and here a short glimpse of what the new marketplace is going to look like. Because right now, when you're choosing the best providers nodes, it's like first come, first serve. So if the node is fulfilling the requirements, like these performance requirements, and have a nice price, it's gonna get a task. But we can do better. It's like this adversarial multi-armed bandit problem. So you can imagine a guy in Las Vegas playing one bandit and having just a limited amount of coins and wanting to maximize his earnings, so he can try different machines and use the one that he already knows that have like high probability of winning and high reward, or he can try new ones and building information about the probability distribution of their computation there. And there is a proposed algorithm, and don't care about the equations here, like we're going to publish the white paper with these results later. It's just for the demo or for this talk. Okay?